Alright, so let's take a look at the second part of section 3.2. So we're still talking about linear functions. Can someone just break that down for me? Like, let's start with linear. What does linear mean when you draw it? Yep, line, straight line. And a function, what does that mean if you draw it? It passes what test? Yep, Nicole? It passes the vertical line test. Now, if you don't draw it and you have a table, how do you tell by looking at a table that it's a function? Right?
Is it repeats?
We have to focus on repeats. What are we looking for? Are we looking for repeats in the x's or the y's? Do we want repeats? Do we not want repeats? But it's something to do with repeats, yep?
Yeah.
It's in the x's, and we don't want repeats. All right? So if you have a table and there's no repeats, you're good. You have a function. Okay? All right. So the first blank you have, it says a blank, and then you got a little bit of space. You should, in that space, put a solution of a linear equation in two variables. So a solution to a linear equation, it means an equation that if you drew it would be a straight line, is an ordered pair that makes the equation true. Right, and I'm gonna show you guys an example. Let's say 2x plus 4y equals 8. Now, as far as, well, how many solutions are there to this? Infinite. I can come up with infinitely many numbers that make that true. Okay. Here's one that would work. 0, 2. Let's try it. That's x, that's y. If you plug 0 in for x, what's 2 times 0? 0. Plus, now plug 2 in for y. What's 4 times 2? 8. 0 plus 8 gives me exactly what I'm supposed to get, 8. So that's one solution to that equation. One out of, again, millions. There's infinite. Anyone think they could give me another solution? Two numbers, one you could plug in for x, one you could plug in for y, that would make that true. Chris, you think you got one?
What?
Think you got one? Not sure? No. Yeah. Let's try 4, 0. Let's check it. If you plug 4 in for x, 2 times 4, 8. 4 times 0, 8 plus 0 is 8. Perfect. Another one would be, I'm going to do one more, and that's the last one I'm going to do. Let's do, let's make x2, and let's make y1. 2, 1. 2 times 2 gives me 4. 4 times 1 gives me 4. 4 plus 4? 8. So there's another one. Okay? You could just keep coming up with them. Okay? You could get... Luckily, I thank you. You could get positives, you could get negatives, you could get fractions, you can get decimals. Fractions and decimals are harder to do in your head. But there's a couple solutions. So, everyone understand what I mean by solutions to linear equations? They're coordinates. That's all. Coordinates. So, the graph of this, right, is all those points and all the ones that I didn't list. It's every single point on that line. That's what the graph looks like. Okay? So that part you just need to read it. The graph of a linear equation in two variables is every single point that makes it true. So when you graph it, it would look something like this. But there's so many points together that when you have them all that close, it looks like they're all connected, and that's why we get a line. Okay? So you think of a line as just like millions and millions of points, all really, really close together. Okay? That's not exactly, but it kind of helps if you think of it that way. All right, so I mentioned these two words before we started today. We have discrete and then the word continuous. So on your notes where it says sometimes the domain of a function is discrete. Okay? Discrete means only certain numbers are allowed. Okay? My example to you was you go online, you buy tickets. Okay? If you want to buy tickets to go see a show, you might be able to buy 5 tickets, 6 tickets, 7 tickets. But you can't pick fractions. They're not going to sell you 5.2 tickets. They're not going to sell you 5.6 tickets. The domain for that, you can only pick certain numbers.
Like the word mistake, it's going to be something like real, you know what I mean? Like a car, or tickets, or t-shirts,
Yeah.
donuts. Like we did the one the other day on the gulps.
Yeah.
You can only take you can only take one. I know, I shouldn't have made it. I just opened up a whole can of worms. I didn't want to open up with the gulps. We had a hard time with that the other day. But you can always, again, stuff like that, you can't have a half of one.
Yeah.
Right? You know, it's either all or nothing. Or like number of nights you stay at a hotel. Number of books you buy, number of DVDs you buy. You can't buy a half, you can't buy a fraction.
Now
It's
what
either
about
all or nothing?
Now what about, like, let's say the temperature this morning was 40, and then at noon it's 50.
Well, that's what happened today.
So if the temperature went from 40 to 50, at some point was the temperature 42?
Maybe.
I mean, could the temperature go from 40 to 50
It's
and
impossible.
not be 42?
No.
No. If something's warming up, it can't skip a temperature, right? So at some point, would the temperature be 45?
Yes.
How about 46.1?
No.
Possibly.
Yeah,
Not possibly. Guaranteed. It has to. All right? If the temperature is warming up, you're going to go through every single possible temperature from 40 to 50. At some point, it will be 48.275. Whether you measure the temperature at that time, that's another question. But it will be. You can't go from 40 degrees to 50 degrees without going through everything.
You can't skip 9 degrees.
Yeah, you can't skip. You go through everything. So that's a little different. Okay? So let's graph the numbers 1 to 5. Okay, so I'm going to make a number line. And it says integers. So what kind of numbers are integers? Integer means that it's not a what? It's not a decimal. So that means we graph a number like
It's not a decimal or a fraction.
1, 2, 3, 4, 5. If you're counting by integers, is there anything between 2 and 3? No, you're not allowed decimals. So there's 2, there's 3. There's nothing in between. There are only certain numbers. So that's how you graph it. Okay? When you have something that's discrete, the graph looks like dots. Okay? Dots that show you each value you're allowed to pick. When you have something that's continuous, it's going to be a shaded in line. Okay? It's going to be a connected line. Think continuous, connected, discrete dots. That kind of works. All right, so the next one I've already been talking about is continuous. All right, so continuous means it includes every single possible number between a start and an end. Everything. Every fraction. Every decimal. All right, so another example would be like if I took this little plastic thing, right, and I measured how high it is off the table. Let's say it's 2 feet off the table. As I drop it and it starts to fall, will there be a time when it's only 1 foot above the table? Will there be a time when it's exactly 8 inches off the table? 8.6, 7.2 inches, 1.44 inches. Yeah, it's going to go through every single height from where it started to where it finished. Right? If you could watch it in slow motion, you could measure it at any time between 2 and 0. So it would be every single number, every fraction, every decimal. And I think we're going to do a graph of that next.
And guys, continuous is like, we're going to give you like word problems. Right? Continuous is usually going to deal, like Mr. Hager just said, units of measure. Inches, ounces, feet. You could deal with one like number of calories. All things that you use a unit of measure to look at. Right? Those are going to be good examples of continuous because it's going to fit our temperature. It's going to fit in that range of numbers. You can't go from like 1 inch to 2 inches. There's a whole bunch of measurements in between 1 and 2 inches. It can't be 1 or 2, right? So discrete, it's all or nothing, right? Continuous is kind of everything in between that range.
So let's again go back to that example where it was 3 feet off the table. So there's a time when it's 3 feet. There was a time when it was 2.9 feet, 2.8, 2.7, 2.6, all the way down to 0. So anything in there is an answer. Okay, so continuous, the line is connected. Discrete, dots.
Say, can you underline everything after which until the comma, so contains all numbers in a certain interval? That's what they have to write in their guidance. Thank you. Yeah, continuous is connected. Like Mr. Hager said, continuous, connected, discrete dots. So discrete is all or nothing. Number of nights you stay at a hotel, number of cars you bought, number of DVDs sold, right? It can't be a half. It can't be any fractions. But if you're measuring something using like ounces or weight or inches, whatever, it can't, like you can go from like between 1 pound and 2 pounds, you can be like 1 pound 3 ounces, 1 pound 2.76 ounces. There's a whole bunch of numbers in between.
How about money? Is money discrete or continuous?
Discrete.
Discrete, because you can't have any dollar amount you want. I mean, we have parts of dollars, but you can only go to a penny. You can't go smaller than a penny. So there's no such thing as like $2.654. You can have 2.65. You can have 2.66. You can't have anything in between the two. All right. So, reminder, okay, how we graph a function. Yep, there's a table for this. You're going to see a box, 4 boxes. We're going to fill in those boxes.
Yes, it says you have recall, but then like steps 1, 2, and 3 in the boxes you have to fill in.
So when you want to graph something, we're going to make a table. Okay, we just did it. I'm just going to go back to the warm-up for a second. We basically made a table. We didn't fill in the coordinates, but we'll do that. That shows us how to graph something. A domain value, a formula, a range value, and then a coordinate. Okay, so that's the table we're making right now. So the first box, I called it domain, same as input. Okay. You pick a number you're going to plug in. That's an x value. In the next box, you're going to have a formula. So this will be some kind of equation.
So you put equation given.
Right? It might be like 2x plus 6 or 5y minus 7. It'll be an equation.
So what we're gonna do is some word problems, right? So we're gonna give you'll see in the actual word problem the equation will be given. You'll never have to come up with it on your own, it'll always be given to you.
Column 3 is a calculation. Whatever you get when you do out column 2, we're going to put the answer in column 3. That's the y value.
That's your answer.
And then the last column, that's just a coordinate. How do you get the coordinate? Well, the first number comes from the first column. The second number comes from that column. X comes from the first column. Y comes from the second. And then once we have a few coordinates, we'll have something like this. We'll have a few dots. We just have to decide if it's a discrete problem, we leave dots. If it's a continuous problem, we connect it. It depends on the problem. All right, so step 2, I kind of already said it. But after you get the coordinates, you're going to graph them. Just like that. Put your 4 dots. Or 5 dots, or however many dots you have in your domain. I think in the warm-up, I think we had nights of lodging. We had 0 through 5. So 0, 1, 2, 3, 4, 5. It's six dots. And then decide if you should connect the dots if it's discrete, or connect the dots if it's continuous, or leave them as dots if it's discrete. So I'll just put down below here a little picture. Discrete is the dots, continuous, connected. That's the difference. Okay, everyone. If we have to draw a line, generally it's kind of nice if you can use like the edge of your ID or something just to make it, look nice and straight. None of the graphs are that big, so it's not like you're going to need a ruler. But your ID would be a good thing to use for like a straight edge. All right. So first example says the linear function y equals 15.95x. So that's our formula. Represents the cost in dollars to buy tickets at a museum, to buy X tickets. Each customer can buy up to 4 tickets. So they're giving us a limit. You can't just fill in anything you want for the number of tickets. You only can go up to 4, including 4. Okay. Find the domain of the function. Is it discrete or is it continuous?
So guys, based on that maximum of 4 tickets, we're going to have 5 numbers in our domain. What are those 5 numbers going to be?
0,
Yeah.
2, 3,
0 on this one.
1, 2, 3, 4. So there are 5 numbers in the domain.
As Hager said, it's giving us a limit. We can only go up to 4. Again, when you do these, you want to do 0. Because 0, you could buy no tickets. You could not buy any. If you couldn't buy, you don't have to buy any.
Any question on how we got that domain? 0, 1, 2, 3, 4.
So we can buy up to 4. That's why we went 0 through 4.
Now, would that be discrete or continuous? That's discrete. Okay? It's discrete because you're not picking every single number between 0 and 4, like 1.1, 1.2, 1.3. There's no fractions, there's no decimals. You can just pick 0, 1, 2, 3, 4. Discrete numbers.
So you can't buy 1 3/4 tickets. You can either buy 1 or 2, 3 or 4.
So now,
anything in between.
let me set that up in our table. So we've got 0, 1, 2, 3, 4. The second column, go back, that's my formula. It's my equation. So I got y equals 15.95x. The third column, that's going to be my y value. And the fourth column, that's going to be a coordinate. Okay, so what's the, did we already have the table down here?
No, I'm saying.
Okay.
Because I'm testing not to make their own table anyway, so I don't want to get into that habit of giving it to them.
All right, so what's the first value that I'm going to plug in for x? 0. So I'm going to do y equals 1595 times 0. Okay, we should be able to do that one without a calculator. What would y be if you do that out?
0.
0. So what would be the coordinate? 0, 0. You buy 0 tickets, you spend 0 money. 0, 0. All right, the next one. I'm going to plug in what? Because we're going to buy how many tickets? Done? 1. We'll plug in 1. All right, I think we could still do that without a calculator. 1595 times 1 is how much? It's 1595. So now our coordinate, 1 ticket, costs 1595. So all our coordinates here are ticket, comma, money. Tickets, money. The next one. How about Brady? What am I plugging in for x with the next one? Times 2. So I'm just going to fill these all out. Times 2. 1595 times 3. 1595 times 4. Right, and let's see what we get. So 1595 times 2 gives me 3190. Why did I put 90 instead of 9? I mean, it's the same thing. Because it's money. Yeah, money we usually put 2 decimal places. When you look at a price tag, you'd never see a price tag that says 31.9. It would say 31.90. 1593, whoops, 1595 times 3, 4785. And 1595 times 4. 1595 times 4 is 6380. Okay, so let's write our coordinates. Alex, what's going to be my coordinate, my next one down? 2, yep.
31.90.
And then 3190, yep.
You're taking the first column and the third, the first column and the third column. That's where we're getting those numbers from.
Ellie, how about my next coordinate?
You put 3.
Yep.
And then 47.85.
4785. And then my last one is 46380. Now, what am I going to do with all of those things I just put a box around? I'm going to plot them. All right? Those y values are kind of big. So we're probably not going to want to go by 1s on the y-axis. How about 1s on the x-axis? Is that okay?
Yeah.
Yeah, I would say that's okay. So this will be 0, 1, 2, 3, 4. And what is that again? 0 through 4.
The domain.
It's the domain, but what is it in the word problem?
Discrete.
Thinking like
Oh,
tickets.
Obviously it's discrete.
So tickets. So make sure you label that axis tickets. How about my y-axis? We have to go up to 63. So what do you think? 64, yeah. What do you think would be good to go by? By 10s? Yeah, I could go by 10s. I'd say 10s is probably pretty good. So we'll go 0, 10, 20, 30, 40, 50, 60. And I'll go to 70 since I got to go a little above 60. I got to go to 64.
Graph is so small.
I can't see this graph.
Yeah, it's a little small. Sorry.
Hey guys, on your graph, if you gotta go every on the y-axis, if you gotta go on every other line, that's okay too. So first line 10, skip a line, 20, skip a line, 30, just go every other. So you have a little more space. Okay.
How about, what's that axis again? 0 through 70, that represents y, which is the cost. So let's put cost there. All right, now what I'm going to do, I'm going to make it smaller so I can try to see everything at the same time. 0, 0. That's my first point. My next one is 1, comma, 1595 is pretty close to what number if you're graphing?
We're going by fives.
10.
15, 16, so it's just a little bit below, I would say, put it close to 16. So
It's almost like halfway, a little over halfway between 20 and 10.
maybe about like that. 2, 3190. 3190 is a little bigger than what? A little bigger than what? 30, yeah, so put it a little above 30. So 2, just a little above 30. 3, 4785. 4785, Jacob, a little smaller than what number if we round it? If you go by tens, it's pretty close to... Sure. Dylan?
4785.
Yeah.
It's closer to 48.
Is it closer to 40 or closer to the graph? You have 40 and 50, right? Is it closer to 40 or closer to 50?
Closer to 50, so put it a little less than 50.
That makes sense, Jake? Right, so it's those are the two numbers you have in your graph, right? 40 and 50. It's 4785, so it's closer to 50.
And then 463. So almost halfway towards 70. Okay,
Yeah, a little less than halfway, because it's not 65.
So maybe, I don't know, about in there.
Thinking, guys, we have you graph on these on the test. We're not going to be like super particular on how you graph it.
So 463. All right, now should I connect it?
No.
No, because if I connect it, that means that there are values in between 1 tickets and 2 tickets, and there aren't. So that's your graph. And you leave it just like that.
On the test paper, label it if it's discrete or...
There will be a question, yes, that will ask, is it discrete or continuous?
You may not have to graph it, but you got to know whether it's discrete or continuous. That's the guys. The big thing we wanted to take away from today is being able to identify an example of what's discrete and an example of what's continuous. That's the most important thing for today.
So yes, the domain is discrete. So I just circled discrete. Okay, any question on that? Okay, so this is one where we've got a graph. So we'll do that
So
after.
it's the same thing.
It says the linear function m equals 50 minus 9d represents the amount of dollars, the amount of money you have in dollars after you buy a certain amount of DVDs. Anybody buy DVDs anymore?
No.
Yeah.
Those are whack.
Rent, I don't know. After you buy a certain amount of Netflix subscriptions or something, I don't know, or pay per view. Does anyone do that?
I still watch you.
You still watch DVDs? There's actually still one Blockbuster store left. Forget where it is, but it's like an independent kind of
What
thing
is it
now.
now?
Yeah, but there's one left. I actually have a gift card for $20. I can't spend it anywhere because they went out of business. Anybody want it? I saw it for $20.
Wait, someone switch it up.
It's a good deal. I'll sell it for 19. Give you a good deal on it.
1950.
Yeah, a lot of CD stores have been going out of business.
All right, so it says, I'm just kidding, I'm not saying. Find the domain of the function. Is it discrete or continuous? All right,
So
so
mistake of that last one we did, it gave us a limit, right? So we can only buy this amount of tickets. It's not telling us how much we have, right? So how do we, go ahead, Mr. Hager.
So there's still a restriction here, even though they didn't write it. What's the restriction if you're buying something? Think about if you go to the store and it's a cash-only store. What's the restriction when you walk in that store if you want to buy stuff? Yeah?
You have to have cash on it.
Okay, you have cash. What else? Yeah?
The amount of money that you have that.
You can't go past the amount of money
Don't spend over what you have.
over what you have.
Budget.
So if you tried to spend more than you have, what kind of number would you get? Negative. So what we have to make sure is
That it stays positive.
the amount of money we have left stays positive. If all of a sudden we plug a number in for D and 50 minus something comes out negative, you've now spent more money than you have. how much money does this person have to spend? They didn't write it, but it's in the formula.
If you look at the formula, it'll tell you.
It's 50, right? They have $50, and it's like each DVD costs 9. So you buy 1, take away 9. You buy 2, take away another 9, up to a certain point. So the domain, let's find the domain. All right, what I might do off to the side is I might think, all right, I have $50 to spend. I can't subtract more than 50. So how many DVDs could I afford to buy? I could definitely buy 1. That would only be $9. Could buy 0. Could I afford 2? How much would 2 be? It would be 18. So I can afford 2. I can afford up to $50. So let's add another 9. Can I afford 3? Yeah, I'm okay. Can I afford 4? That would 9 times 4, that would be a 36. 50 minus 36, you're okay. Can I afford 5? Yeah. If I spend 5, if I buy 5, 9 times 5 is 45. 50 minus 45, you're still good.
But you can't do 6 or anything.
9 times 6 is 54.
Yeah, it's over.
I'm over. 50 minus 54 means now I have negative $4 left. That doesn't make sense.
So guys, kind of like the one you did in the warm-up, right? You couldn't go over the number of nights you stayed. The price couldn't go over $900. Just like this, the price couldn't go over 50. That's how you figure out your domain.
So our domain is 0 through 5. Our formula is 50 minus 9D. Actually, we didn't use X and Y. We used discs and money. But what I'm going to do to remember it in my head is I'm going to think of it, discs is like my X, so when I'm graphing it, I'm going to think, okay, discs is X because it's domain. Domain is X. Money has to be the other way. That's going to be like my Y. That's my range. All right, so then D, comma, M. All right, so we kind of already did this, but let's just do one of them together. Okay, what's the first one going to be? 50 minus, what are you plugging in for D? 0. 50 minus 9 times 0. Well, if you don't spend anything, what's 50 minus 0? 50.
If you don't buy any DVDs, you still gotta be $50.
So if you buy 0 DVDs, you still have $50. The next one is 50 minus 9 times what? 1. Let's just fill them out. 50 minus 9 times 2. 50 minus 9 times, how many are we buying here? 3. All right, 50 minus 4, and then 50 minus 9 times 5. And we already did all those numbers. Okay, we kind of were doing them as we go. So we had 50. The first one is 50 minus 9, which is 41. The next one is 50 minus 9 times 2 is 18. 50 take away 18 is 32. I'm just subtracting what number each time from how much money I have left.
So to go from 50 to 41, to go from 41 to 32, what's the pattern?
This is linear, so it has a pattern. It's the same number each time. We mentioned that yesterday. What is it?
Up or down? Down.
Down.
Right?
By how much? 9. Down 9, down 9, down 9, down 9. Till finally we go down. When we buy 5 DVDs, we've spent $45. We only have 5 left. And now we'll write everything as a coordinate. So 1, 2, 3, 4, 5. And the money amount, 41, 32, 23, and 5. Okay, what should I go by on my x-axis? What would be a good scale? Oh, no?
What numbers would you use?
I would go 0 to 5.
Yeah, I think 0 through 5, just going by ones is fine. So we've got 0 through 5. And what does that represent? Up to 5 DVDs. Now on the y-axis, that's the cost to buy, how much money we have left. What should I do on the y-axis? Yeah, I think 5s would probably be good. So let's go 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, and now graph our points. So the first one is 0, 50. We don't go left and right, we go up 50. That's your money that's left. What's the next one? We have 0, 50, then... Oh, Bethany, what's my next coordinate? 1. If I buy 1, I have 41 left. So 41, just a little above 40. Nate, my next coordinate? 232. Let's see. So yeah, sorry, I wrote my numbers. That's 141, 232. I just got a little squished in there. 323, 4, 14. Did I miss that one?
Yeah.
When I was writing them down? And then 5.
Yeah, 423 mistake.
There we go. All right, so 232. So 232 would be a little bit above 30. 3, what's my next one? 323. So 323. Be right in there. Next one, 414. 414 looks good. So far they look pretty straight. That's how they should look. They should look straight. And then 5, comma, yeah, 5. So 5, 5. Now should I connect them?
Yeah.
So connecting them means you could rent any number of DVDs you wanted between 0 and 5. Could you pick any single number between 0 and 5?
4.5 DVDs.
No, because this one is discrete. Okay, that's discrete. Any questions on those two? Okay, so the last one we'll take a look at, which will be a continuous example.
Alright, so this one, example 3 says a cereal bar contains 130 calories. Number of calories consumed is a function of the number of bars eaten. Right? So is this going to be a linear function? So when I graph it, will it give me a straight line? Yes or no?
No.
It won't?
Oh, you will.
It will. This is, again, this is going to be a linear function, so yeah. So does the situation represent a linear function? Yes. All right?
Oh, that's right.
For that, again, that's all we have to do. Now, this one's a little bit different because it's not giving me, right? It's not giving me a function.
That
Right.
first part where it says it's a linear function, that actually might be easier to answer after
After
you
we do it.
sketch it. So it's a lot easier once you see a picture then you can do it. So if you're confused on that, we'll come back to that part.
Yeah.
And I think on a test, that part would be
At the
after,
end.
at the end.
Again, we may, again, like we've been asking you if it's discrete or continuous at the beginning. Again, we may ask you at the end, once you graph it, whether it's discrete or continuous. All right? So, but this one's a little bit different because we don't have an actual formula. The ones we did before, we had a formula. The one we just did was like, what was it, 50 minus 9d, right? We don't have that for this one. So we're gonna have to figure out what we want to use for a formula.
Go ahead, Josh.
Alright. So once we go back up, we'll have a better idea of so number of calories consumed by the number of bars eaten. Alright? So I know when I set up my formula, I'm going to have an equal sign. Alright? What number is going to be in that function? 130. I'm going to put the 130 after or to the right of the equal sign. What letter do you think is going to be next to that 130? Right? B, right? Because for every bar that we eat, it's 130 calories. So you can plug in the number of bars that you eat here, and you'll get 130 calories. All right? What's going to be here? So we use B for bars. Again, now I want to, when I plug 130 times however many bars that I ate, what am I going to get? The total number of calories. So what letter might I want to use? C. So again, this one didn't give you a function. You had to set it up. So C equals 130B. When I multiply the number of bars times 130, that'll give me the total number of calories. All right? So again, C stands for calories, then B stands for, again, number of bars that I ate. All right?
Now, do they give you a limit on how many bars you can eat? No. It's unlimited. So when we draw our sketch here, we're going to see something a little different. It's like it's going to keep going. There's no limit. Now, there obviously is a practical limit. We can only eat so much. But again, they don't say you only have 5 bars to eat or 20 bars or 50 bars. There's no limit on the number of bars. So what we're going to do is we'll probably just find a few. Maybe we'll try 0 to 5 bars or something.
Yeah.
And I think that's enough. You'll see a pattern. That'll just keep going.
Again, my B, if I go back to one before, right? Again, D, right, was what I plugged in. M was what it equaled, right? D is what I'm plugging in. M is what I got for an answer. Same thing here. My B, when I set up my chart, my B will be first. I'll leave a little space. I'll have my my C, Then I'm going to have
Or B comma C, right?
Yeah.
or figure like that, B, comma, C. All right? So in this case, like we did in the last one, right? Which is going to, when I graph it, right? Which letter is going to become my X when I'm graphing it? The B or the C? The B is going to be my X. And the C will be my Y. What's going to go right here in between the B and the C? Ellie?
130B.
130B. Like Mr. Hager said, we're probably going to do like 5 bars. All right? 0 through 5. All right? So 0, 1, 2, 3, 4, 5. A little bit more organized this time. So, the first thing I'm going to write inside, the first thing in the second column I'm going to write is going to be what page? What am I going to write in this box right here?
130.
Yeah, 130, parenthesis, 0. Below that, Ryan, what am I going to write in the box right here?
130 parentheses 2.
130, 1, and Ryan just did the second one for us too. 130 parentheses 2. Nathan, what about after 130 parentheses 2? What am I going to put after that? 130, 130 parentheses 3. I think you guys get the idea. 130 parentheses 4, 130 parentheses 5. Again, like we've done on all the others, I'm just taking whatever this is. Take whatever this is, take this letter, plug it in the actual formula. Alright? And then when I do the math, that's going to give me C. Alright? Or when I graph it like my Y. So my first C value, or number of calories, if I don't eat any, Miguel, how many calories do I gain? 0. Nicole, if I eat 1 bar, how many calories? 130. Numbers are getting a little bit bigger now, right? So I may, say it's making a little bit bigger too. I may want to use a calculator now. What am I going to punch in on my calculator? Ellie?
130 times 2.
130 times 2, 260. What am I going to punch in the next time?
130 times 3.
130 times 3, like Yusuf said, 390. 130 times 4, 520. And the last one, 130 times 5, right?
Yeah.
130, what do people say?
I said 680, but it's
650.
50.
Alright, cool. So my first coordinate's gonna be what? 0, 0. Jake, what's my second coordinate gonna be?
1.
1 comma,
The same number as last time.
1 comma,
0.
no, because look at my first coordinate, B was 0, C was 0. That's why I got 0, 0. For this one, I had B as 1, how about C? B, C, right? B was 0, C was 0. B was 1 in this case. What about my C?
1.
1 what? So what was my second C value? The first one was 0, right? What's the one below it? 130. Again, I'm looking at this column, Jake, and this column together, right? 130. How about Alex? My third coordinate.
2, 6, 260.
2, 260. How about Laurel? My fourth coordinate. So I just did 2, 260. Now I'm here. Fourth. 1, 2, 3, 4. When I plug, I know what you're getting at. When I plugged in 3. So what did I get for my coordinates when I plugged in 3? 3 and 390. How about after that? Garrett, after that, what do I get? After my 3, 390?
4, 5.
4, 520. And then, last but not least, I'm going to get 5, 6. All right? So if I scroll down, just want to make it a little bit bigger. where I can see everything. All right. So, how about Savannah? How do I want to label my B's or my X's? What would be a good way to number them?
1 to 5.
Yep, 1 through 5. 1, 2, 3, 4, 5. And that's what? What should I label that, Mary?
Bar.
Bars.
But shouldn't it be 0?
Zeros here.
Oh.
So that's going to be bars. Now, what's a good way to label my my Y's or my C's? I don't think I'll fit them all because I'm going to be up to 660. So I'm not. If I go by tens, I ain't going to make it.
Hundreds? 130s?
Go by 130s. You get an actual amount every time. It would work. That's fine. We'll go 130. We'll go 260. We'll go 390. We'll go 520, and we'll go 650. That's a good way to do it because then we're gonna end up on it every single time. All right. So I'm gonna do 0, 0, which is right here. 1, 130, right there. We're gonna get nice points every time, so we went by 130s. 2, 260. 3, 390. 4, 520. 5, 650. All right? So, is that going to be a linear function?
Yeah.
Why? Huh? Yeah, like Chris just said, right? Linear, line. It's got to be straight. Yes, it's a linear function. All right? So, like Mr. Hager said, does this situation represent a linear function? I'm going to squeeze it in and say yes when it's graphed. It's a straight line. All right? Now, is it going to be, should I be connecting those dots?
No.
I'm dealing with bars, right?
Yeah.
Could I eat half a bar?
Yeah.
Right? Could I eat a quarter of a bar?
Yes.
All right. So this is going to be, what should I do to my graph? Connect the dots.
And does it stop at 5 bars? Could you eat 6?
Yeah. Again, I can keep, we didn't do all of them. We can eat as many bars as we want. So I can just keep this line. Again, I should have done a straight line. But again, I'm going to do an arrow on the end just to show that I can keep going in that direction. So this is going to be, because with bars, you could eat a half. You could eat a quarter. You could eat whatever.
Break off any little piece you want.
Yeah, and I'll give you a little bit of like 0.2% of the 0.2 of the bar. All right, you can do that. All right. So this would be continuous. So it's everything you can get 152.5 calories depending on how much of the bar that you eat. You could eat a bar and a quarter. All right. So that's going to be continuous. So make sure you connect the dots. All right. Tonight's homework. We got 2 word problems on the front, like we did today, discrete and continuous. On the back side, there's all review stuff from the week. All right. That should say, yeah, the reference sheet, guys. I'm pretty close to done. I'm gonna have it up on Google Classroom by this afternoon. All right. I'll probably go back to my room. I'm not free till like 11:15. So once I'm free, I've got a few more things I gotta add on there. So it'll probably be up by the time you guys get out of lunch. Right, by 11 o'clock it'll be up. So if you want to print it off and start it, you can. The majority of the stuff that's on there you have. The only stuff you don't have is the stuff from section 3.3, which we're gonna do tomorrow. All right. Again, first test of second quarter is on Friday. All right. So again, if you didn't do so well for the first quarter, maybe you haven't been filling out the reference sheet as well as you need to, you may want to start doing that so you can do a little bit better during the second quarter. And again, second quarter is, again, it's kind of spread out. You know, it doesn't end until like the end of January. But again, it's a lot of time. We have a lot of time off too because of Christmas, because of Thanksgiving, a double shop week for you guys. So again, you want to make sure you get off to a good start. Report cards, guys. Again, whenever you have period 9 on Friday, that's when you're gonna get them. Alright? Again, it's up to the teacher how they want to do it. Some give them out at the end. If you have a test, they may give them out after the test. Again, it's all up to, as long as we get them to you by the end of the day at 2:40. Again, the teacher may give it at the end, the middle, I don't know. It depends on who you have. No, we're not doing that. Alright, so we're running out of time. Alright, so guys, tomorrow we'll try to get through the lesson relatively quick. Hopefully by 8:30 or a little after we'll be done. That way you guys can do some practice problems. Maybe we'll do some bonus points tomorrow.